and we have to cover from starting the basic question to the advanced question. So the first question arises: what are the different type of RFID tags and how they work? So actually there are different three type of RFIDs. Okay. Mm, so first one is passive RFID, in which no external battery are required and no internal battery is required, and the power only when the reader send a RF signal. Okay. On receiving the reader signal, the tag antenna generate a small current. So after receiving the reader signal, a tag automatically generate a small current and power the chip and send back to the ID using the backscatter modulation. Okay. So this one is passive dependent. Okay, no external. So its range is 10 centimeter to few meter. So cost is cheaper. Retail access card library tag. Okay. So reader send EM wave, tag harvest the energy, and tag modulate the signal. Okay. Active contain their own battery. Okay. Battery power both the chip and transmission. They continuously transmit activate and they continuously transmit or activate the reader command. Okay. Range from 100 meter to 1 kilometer. Okay. The cost is very high. So application is vehicle tracking, container tracking, and the mining and toll system. Internal battery tag actively send the signal. Reader receives strong RF signal. Okay. Semi-passive, in which battery assisted passive. So RFID has battery, but battery only power chip, not the transmission. Transmission still use backscatter like passive, and more than passive but less than active. Okay. Active, passive or semi-passive, environmental sensing and these things. So the difference between near field and far field. So see the image. Uh, this one is reader and tag. Okay. And this one is far field. So near field mean that. So near field, I think I'm audible or not. Oh, okay, everything is okay. चलो बैक बाल किधर घुमावा है इधर या इधर थोड़ा जाके ना इधर so near field use LF use low frequency of this one and high frequency of this one. Work like a transformer coupling between the coils. The reader and the tag from the electromagnetic fields. Okay. Short ranging up to 10 to 20 centimeter. Data transfer by changing the magnetic field. Okay. Far field, in which we use ultra high frequency ranging from this megahertz to the microwave. Reader send a far field electromagnetic backscatter. The reader send EM wave and tag reflect back in the backscatter modulation range in several meter to tens of hundred. So application retail inventory and this far field. Okay. Third question is that third one is frequency range of RFID and their application. Frequency range The frequency of RF, low frequency, high frequency, ultra high, active. Low frequency is 125 to 134 kilohertz. High frequency is 13.56 megahertz, ranging from 0 to 2 meter, as up to 1 meters and this 3 meters. So it costly, this one. Memory 64-bit, and this penetration level is very good and poor. Data is slow for the animal tag, item tracking, and the box palette things. Okay, so frequency range of RFID are low frequency, this one, low frequency view range, okay, penetrate water, and this one, animal tracking and the mobilizer, immobilizer. High frequency it up to the 1 meters, support NFCs, okay, smart card, metro card, level, all these things. Ultra high frequency ranging from this and sensitive to the water and the retail inventory, warehouses, logistic and tooling system. Okay. And third one is microwave. This one up to application for fast filling active card. Challenges of the RFID development for the large scale IoTs. So challenges of IoT signal interference. So metal reflect the RF waves. Signal reflect the RF waves. Water absorb the RF waves. Okay. Human bodies block the signal. Okay. Tag collision and collision. Thousands of tag responses, multiple signal collided. Okay, multiple data interference to each other. Scalability issue. Need huge backend system. Higher latency with millions of tag items. Okay, privacy and security. Anyone can read. Anyone with the reader can access the data. Okay, scheming and eavesdropping and clonings. Cost of development, readers, antenna, and integration with the cloud. Okay, environment factor. Tag reader communication protocol. Okay, tag reader, first of all physical layer, after data link layer, then application layer. Okay, so in physical layer define the modulation and the frequency band. So define physical layer, define the modulation, ASK, PSK, and they define the frequency band like low frequency, ultra high frequency. Define how the transfer and backscatter thing happen. Data link layer, where in which anti-collision encoding framing of data happen. Anti-collision encodings of things, framing of the data happen here. So application layer, EPC, electronic product code. Electronic product code, command like read, write, lock, and kill things happen here. So reader send a command, tag wake up and response, anti-collision resolve the multiple tag, and reader read the EPC and send back to the IoT backend. Tag wake and response and anti-collision things. What is anti-collision protocol and why it is important? Mm, So what is anti-collision protocol and why it is important? Anti-collision protocol allow a multiple RFID to respond to return without overlapping the signal. So actually it is a protocol that allow multiple RFID tag to respond to return without overlapping a signal. Because why critical in warehouse, thousands of tag present without anti-collision protocol, the tag responds simultaneously and signal overlap and the reader cannot decode it. Okay. Ensure that the fastest scanning, so through this we can fastly scan, accurate identification and no missing tag. Okay, types are aloha based and the tree based. Okay, so this is a tree based 32211. So this is tree based one and second one is aloha. So aloha in simply in the queue type structure we simply divide all the segment. Okay, so anti-collision protocol and multiply response the reader without overlapping signal. Okay. In warehouse, thousands or tag present without signal overlapping. Aloha base, random time slot or binary, random time slot and the binary split. Okay. Compare Zigbee and BLE. So IEEE standard for the IEEE standard for the Bluetooth Bluetooth is none. So there is no IEEE standard for the Bluetooth low devices. But for ZigBee, it is given at 802.115.4 for ranging from 203. The frequency band is 2.4, but frequency range is between 915 megahertz to 915 megahertz or 2.4 gigahertz. Okay, max data 1 MB per second. Max data ZigBee is number of channel is 16 in channel 2VR, and the modulation scheme is GFA Gaussian phase shifting and orthogonal phase shifting spreading F. And modulation GFS and OQPSK. Spreading things happen is FHSS and GBD/SSS. Okay, base cell is picnode in the star. Extension of the cell, there is no this type thing, but in the cluster mass and this type of things. Okay, so let's see the difference in ZigBee and this. So based on the range, so it ZigBee is only 10 to 100, 10 to 100, but BLE is only 10 to 15 meter. Data rate actually 250 and something. In BLE 1 MB, okay, and BLE 5 2 MB per second. Power consumption very low, BLE in ultra low. Okay, network topology mesh star or tree, but BLE only use centralized peripheral, that is star. Use cases home, smart home, wearable devices. Okay, Zigbee mesh network for the home automation, BLE optimized short range, low power personal devices. So we have to create the explain the Zigbee protocol stack plus OSI alignment. So in this we simply see the protocol stack of Zigbee. So protocol stack for Zigbee, there must be a physical layer. Okay, after that MAC layer, network layer, application framework, and application profile. So these are the Zigbee alliances. These are the IEEE standard for this one, and this one is so it's physical layer. This one MAC media access control layer or security, network layer, security services things, and the application layers for the developer. IEEE standards and Zigbee specification. Okay. So in physical layer on 2.4 gigahertz modulation channel selection. Okay, MAC CSMA recommend routing of thing. Okay, application layer, application support, sublayer, and the Zigbee device object. Okay, physical layer, data layer. Okay, network layer, and this session presentation application layer. Explain the Bluetooth protocol stacks versus controller versus source. So whenever we have to explain the protocol stack for the BLE, in which simply a physical layer, link layer, HCI, ATCAT, SMP, GAP, and app. Okay, raw data to BLE packets, BLE packets to raw data. Okay, recombination and fragmentation. Okay, controller and host. So the physical layer or link layer and the host controller interface. HCI is a host controller interface. Okay, and then after that, and there's attribute protocol and generic attribute profile with generic access profile gap security manager SM. Okay, so these are the protocol stack for the BLE, in which physical layer, link layer, and the host controller interface HCI. Logical link control adaptive logical link control application protocol L2CAP. After that, attribute protocol, generic attribute profile, generic access profile, security manager. So these are the controller and the host protocol for this one. So controller is a lower level and the host is upper level, in which implemented in the hardware, and the physical layer, link layer, direct test mode, and the host controller interface. Okay, host and controller. The host layer, the upper layer, run in the firmware software, in which we see that L2CAP, logic link, logic link and application, logic link and the application logic link control and adaptation protocols. All these things. SMP security manager protocol add attribute profile attribute protocols Gatman Gaussian attribute profile or gap for the multiplexing the multiple channels the security data model services characteristic. Okay, summary controller radio plus timing host protocol different things. So role of IEEE in the Zigbee. So let's move for the role of IEEE standards advanced Zigbee. So IEEE 802.15 provide the physical layer, MAC, and the low power weapons design. Okay. So why it is important? So Zigbee is built on the top of this one standard. So Zigbee add the network layer, application security, and mass routing thing. So IPTF is the foundation for the Zigbee communication, low power wireless operation. Okay, and this one short. So we have discussed this line. So, so we have to see what are the main component of IoT. So, the main component of the IoT are the the key component of IoT and the rules. First of all, these are the relevant titles. So simply there is sensor and devices that collect the information and temperature, humidity, pressure, GPS that convert the physical parameter into digital signal. For example, that we are using DST11, MPU6050, PIR sensor, GPS modulation, and then after connective modulation networks transmit sensor data to cloud and edge system. The communication option are Wi-Fi, BLE, ZigBee, cellular communication, Internet. Ensure the low power, secure, and reliable delivery. And after that, sensor device connectivity. Then after the edge device and gateway, perform the pre-processing near the sensor. So perform pre-processing things near the sensor, reduce the bandwidth by filtering the noise, convert the non-IP protocol to the IP protocols. Okay. And the storage cloud platform where store the huge number of IoT data, provide analytical and ML process dashboard. Okay, and then after the user interface where the application will display the sensor data and allow to control the mobile phone and all these things. Okay, and then move to the next. So an example of end-to-end IoT network. So end-to-end IoT network. So smart home temperature sensor collect rooms temperature connectivity connected layer sensor data gateway layers push data to internet using MQT address store data and trigger this one application use while this one turn off. Draw and sketch the IoT and draw the skeleton of IoT. The smart things, network, middleware, and the application. These are the key building blocks. So whenever we have to create application, these things. Sensor connectivity and pre-processing things, edge cloud, sense, sensor collect the raw data, connectivity, on. So skeleton of IoT are sensor connectivity, processing things, and application and user. So sensor collect the data, measure this one, processing things near the edge or cloud-based application, alert system monitoring dashboard, user interface. So we have to draw the five-layer architecture of IoT and explain each layer. Okay. So five-layer architecture. Okay. Five-layer perception layer, network layer, middleware layer, application layer, and business layer. Okay. Perception layer of the sensor layer, physical layer of IoTs include sensor actuator. Okay. The network layer transmit data to the cloud and middleware. Transmit data to cloud and middleware support Wi-Fi, 4G, 5G. This one. And middleware responsible data processing, things, storage, security protocol, act as a bridge between hardware and application. Application layer, device services such as smart home, smart health, agriculture. That convert the IoT insight to the business value. Compare IoT stack with the OSI. IoT versus 4G stack. So IoT, 4G stack, physical MAC, RLC, PTFC, RLC, IPN application. IoT perception, network, middleware, business layer. Mention the key application of IoTs. Mention 10 key application of the IoTs, that is smart home automation, smart agriculture, all these things. And I start from the home to agriculture, healthcare, city, industry, great application of this. What are the four pillar of IoTs? Sensing, connective data processing, and user interface. Short discussion and the relevance of IoT SCADA. Short discussion of the relevance of IoT SCADA supervisory control and data acquisition. Supervisory control and data used in industrial automation. IoT enhances SCADA by providing the cloud monitoring and remote control end-to-end machine-to-machine direct communication. IoT is an involved from using internet, cloud man-to-man, wireless sensor network, network of sensor nodes communicating wirelessly. Core part of IoT. RFIDs, radio frequency identification, automating tag and tracking, inventory and supply chain. Okay, these are communication standards. Wi-Fi. Wi-Fi is a frequency इतना data rate something है इतना. IEEE standard is 802.11a.g.a.m.a.c. Okay. ZigBee frequency is 2.4, data rate something very low 0.802.15.4. Okay. Smart home sensor and this thing really data rate 1 MB per second. Okay. Ultra low one for the relevance of communication standards. So enable IoT communication reliably, support ultra low power operation, useful for the long wide area network. Then reader, antenna, middleware, okay, backend server, attached to the object or uh, radiate electromagnetic wave, capture RF response, middleware, backend server, okay. So reader emit RF signal, tie response to the ID with backscatter, reader intercept the signal, middleware filter and send the clean data to the cloud. So difference between Wi-Fi, this one and this one. So Wi-Fi, so write the relative advantage and disadvantage of Wi-Fi, GPN, LoRa. So Wi-Fi advantage very high speed data rate, widely availability present in almost all Wi-Fi, support multimedia, camera, streaming, and this thing. Easy to set up. Okay, disadvantage. High power consumption, not suitable for the battery IoT, limited and congestion. ZigBee ultra low power suitable, for the battery life, mesh networking, greatly, uh, greatly increase range, secure, IEEE standards of this one. Ideal for the smart home, low data rate, need separate Zigbee gateway. Okay, BLE, Bluetooth low energy advantage. Very low power consumption available in all smartphone. Easy pairing things. Good for the short term. Disadvantage limited range. Okay. Very long range. Extremely low power. Ideal for the outdoor and the IoT agriculture home cities. Let's see application of each one. So what is IoT middleware? So IoT middleware is software layer that sits between the hardware and the application. So purpose it integrates several devices, manage the communication, provide a security, integrate different devices, manage the communication, provide a security, store and process the data, offer API for developer, perform device identity. Okay, why needed? Because IoT contain heterogeneous devices, different operating system protocol, Large-scale data, real-time communication, middleware solve this incompatibility. Distinguish between hardware, firmware, software, and middleware. So physical electronics components and include sensor, microcontroller, actuator. Firmware low-level program stored inside the hardware. Control device operation, example ESP32 firmware that handle Wi-Fi. Okay. Software high-level program running on the software high-level high-level program running on the computer's phone. Provide the user interface and analytics. Middleware bridge between the hardware and application. Manage the communication, data sequence, and APIs. Why do we need middleware in IoTs? So we use different protocols. Okay. Genetic use data needs security and identity management requires scalable system. Okay. Middleware handle device recovery, data filtering. Okay. Communication management, protocol conversion, cloud integration, and remote update. Okay. What are the essential components of IoT and middleware? So device management, data management, communication manager, security manager, API gateway, analytic engine. So provision, authentication, firmware updates, storage, filtering, transformation, validation, MQTT, COAP, HTTP bridging, message routing, all this encryption, access control, key management, API gateway, analytic engine. IoT architecture, device layer, communication layer, middleware, device layer, communication layer, and the application layer. Types of middleware, service-oriented middleware, cloud-based middleware, application-specific middleware, event-based middleware, database middleware. So cloud-based, AI, application, smart home, event-based, PubSub, architecture, intuitive, and brokers. Database middleware handles structured and unstructured IoT data. Machine to machine direct communication between machine to machine without human involvement. Work in the cellular, Wi-Fi, Zigbee, etc. Mm, Basic for the auto wireless sensors. Network of the sensor mode communicating wirelessly. Each node has a sensor MCU recognition. MAC is standard for low power wireless. Use ZigBee or LoRa transmitters. Supervisionary control and data acquisition used in industrial automation, monitor the machines, pipeline, power grids, and IoT enhance SCADA by enabling the cloud connectivity, real-time remote monitoring, predictive maintenance of RFID. Use RF web for automatic identification. Consists of tag plus reader. Okay. Work in supply chain inventories, hospital, special for the IoT sensor, industries 4.2 and IoT. Fourth industrial revolution, use IoT, AI, robotics, cloud, cybersecurity. Smart home and IoT device automate the task. Okay, think precision of this one. Healthcare, LAN and WAN. Low pan, low WAN, so low power personal area network. Body area network. So sensor and body area network is sensor human devices. 20 sensors. Temperature, humidity sensor, high accuracy temperature, gas leaking sensor, barometer, accelerometer, location tracking, ultrasonic, object detection, human sensor, irrigation, smart sensor, satellite, blood wear, pulse meter. These are the sensors. Actuator, servo motor, DC motor, step motor, buzzer, feeding coil. TIOT use smart. The difference and similarity of the edge and cloud computing: location near to a device, remote at a data center, latency very low, latency is very high, processing local, large scale. Okay, reliability, work offline, need internet, security, high but not but high but remote. What is this computing, library-based computing? Reduce latency, enable real-time decision making, reduce the cost, increase the privacy, even work even without internet, automate the cars,